Good morning. How is everyone? This is 8.1, adding and subtracting polynomials with the none other but the Mrs. Urso. Yes, I'm in rare form today, so those of you who are listening online, just stand by because we are going to have some fun. Okay, so we're going to talk about polynomials, and we're going to talk about three specific types. A polynomial is a monomial. We have already talked about monomials back in chapter 7. A monomial is one term, or it could be the sum or difference of monomials. So a monomial, mono, the prefix meaning one. A binomial is the sum of two monomials. Remember, it could be the sum or difference, so bi meaning two. And a trinomial is the sum or the difference of three monomials. Polynomials that have more than three terms have no special name. They're just called polynomials. The prefix poly meaning, it's okay, thank you. The prefix poly meaning many. Okay? The degree of a monomial is the sum of the exponents of all of its variables, and the degree of the polynomial is whichever term has the largest degree, that becomes the degree of the whole polynomial. So we're going to look at this all very easily in a couple of minutes. So let's just look at our chart here, and let's determine whether each expression is a polynomial. If it is, then we need to identify it by giving it a name. Is it a monomial, a binomial, or a trinomial? And let's remember something we learned from chapter 7 and carry it over and not forget that a monomial or a polynomial can never have a variable in the denominator. So our first one is 3x minus 7xyz. Okay, I see two terms. I don't see any variables in the denominator. I would say absolutely yes, this is a polynomial. There are two terms. They are not alike, meaning they can't be combined. This can't be simplified to one term. And does it have a special name? Yes, it does, because when you have two terms, it would be a binomial. Now we're going to talk about the degree of a polynomial here in a minute, but I'm going to take a little walk over here, and I want to just encourage you to listen and to watch how, again, we would find the degree. So if I want to find the degree of a term, so if I were just to give you a monomial, and it was 7x squared y cubed z to the fourth, it is the sum of all the exponents. So the degree is the sum of all the exponents. So that would be 2 plus 3 plus 4, which would give me 2 and 3 is 5, and 4 is 9. So the degree would be 9. If I gave you x squared, what would the degree be, guys? 2. If I gave you the number 17, there are no variables associated with it. So a number by itself has a degree of what? Anybody know? Of 0. Very good. It has a degree of 0. Let me explain why. Why? It has a degree of 0 because it might look like this. 17x to the 0 power, and x to the 0 power equals 1, and 17 times 1 is equal to 17. Have I changed the value of the original expression? Okay, so that's how you would find the degree of a term. Let's show you how to find the degree of a polynomial. And I always say, well, it's kind of like a game. It's kind of like a game. So if I gave you 4x cubed y squared plus 2xy to the third minus 4xy plus 15. So to find the degree of a polynomial, step number 1, find the degree of each term. Okay, so let's find the degree of each term. And what I basically do is I just go ahead and I just write it right underneath. So the degree of the first term would be 2 plus 3 or 5. The degree of the second term would be 1 plus 3 or 4. The degree of the third term would be 1 plus 1 or 2. And the degree of the fourth term would be 0. So you find the degree of each term. Which term has the greatest degree? That's the degree of the polynomial. So it's whoever has the highest number wins. So what would the degree of this polynomial be, guys?
5.
So the degree is 5. Why? Because 5 is bigger than 4, 2, and 0. Does that help? Yes? Okay, so let's go ahead and go back over here for a minute and let's look at these. Okay, negative 25. Okay, it's a number. It's a real number. It's one term. So it's a monomial and it has a degree of 0. Remember, we just addressed that. A number by itself with no variables attached to it has a degree of 0. 7n cubed plus 3n to the negative fourth becomes 7n cubed plus 3 over n to the fourth, which is not a monomial. Why? Why is 3 over n to the fourth not considered a monomial? A variable in the denominator. So if your answer is none, obviously you're not going to fill in a degree. And then we have 9x cubed plus 4x plus x plus 4 plus 2x. Okay, so this is an important one because you always have to see if you can combine like terms. And you can. So this is 9x cubed. We have a 4x and an x and a 2x, which gives me what? 4x plus 1x is 5x plus 2 is 7x plus 4. So it becomes 9x cubed plus 7x plus 4. So how many terms are there? 3. Is it a polynomial? Yes. Is there a specific name for a polynomial that has 3 terms? What is it? Trinomial. And what would the degree be? 3. Is that helpful? Yes? Okay, so I'm going to give you a chance to just look at a couple of these. Determine whether each expression is a polynomial. If it is, find the degree and then determine is it a monomial, binomial, or trinomial. So I'm just going to give you a couple to do. You're going to do 1, 2, 3, and 4. Okay? Those of you listening online, we have not forgotten you. We're just working on a few problems, so you go ahead and try them as well. what we've got. Let's look at number 1 together. Number 1 is 36. Who has it? Raise your hand. Let's go. In the back. Yes. It's a monomial, so yes. And it's a monomial. Great job. How about number 2? Number 2, somebody else. Okay, right here. It's no, and it's because it has a variable in the denominator. Oh, and we needed to name the degree on number 1. What would the degree be? Yes. 0. Good job. Okay, number 3. Number 3, yes. It's a binomial because you can combine it and it would become 6x minus 5. So it's a binomial. And what would the degree be? 1 is correct. And number 4. Number 4, last one. Who wants it? Going once, twice. Sold to the young man right here. And the degree would be what? 3. Good job. Does anybody have a question on how to determine if something is a monomial, binomial, or trinomial, and how to determine the degree of a term, pardon me, or the overall degree of a polynomial? To find the degree of the overall polynomial, one more time. To find the degree of a polynomial, you find the degree of each term. Whichever number is greatest becomes the degree of the whole polynomial. So in this example, the degree of the first term was 3 plus 2 or 5. The degree of the second term was 1 plus 3 or 4. The third term had a degree of 2. And the fourth term had a degree of 0. Now ask yourself which number is bigger, and that becomes the degree of the whole polynomial. Does that help? Are you sure? Let's look at one more then. Okay, so let's look at number 6. Okay, 6x plus x squared. Are any of the terms alike, yes or no? No. So is it a monomial, binomial, trinomial? It's a binomial. What's the degree of the first term? What I'm asking right here because I want to make sure she understands. Thank you, though. What's the degree of the second term? Which number is bigger, 1 or 2? So what's the degree of the polynomial? Outstanding. Does that help? Okay. Good job. All right. Let's move on to writing a polynomial in standard form and identifying the lead coefficient. Okay? Okay, this is important, so let's just go ahead. I'm just going to highlight this for you because I really want to make sure that we start doing this because it is important and it's really going to help us in this whole chapter. The terms of a polynomial are usually arranged so that the terms are in order from greatest degree to least degree. This is called or known as standard form of a polynomial. Now, guys, we usually, when x and y are involved, it's easy. Everybody, let's stay awake. Come on. Waking everybody up online as well. Okay. X and y are easy because x comes before y, so we usually do it in alphabetical order. So if there's an x and a y involved, the lead variable would be the x, and we would go from x cubed to x squared to x to the first. So let's go ahead and take a look at a couple of these just so you have an idea of what's going on. So we'll use one of the examples here that they've given us. Okay. And we'll get rid of the highlighter and go back to a pen, I think. So here we go. And maybe not. And maybe not again. There we go. And I'll abbreviate polynomial as poly in standard form. Okay, so we have x cubed plus x to the fifth minus x squared plus 2x. Okay, so basically what you're looking for, it's kind of like going back to elementary, is you're looking for the line leader, and we're going to put them in order. So this has a degree of 3, 5, 2, and 1. Which one's the biggest? Okay. So find the greatest exponent of the x variable. In this case, it's x because this is all we're dealing with. And write in descending order. And I'm going to give you something that's going to help you remember what descending means. Descending means we're going down the stairs. We're going down the stairs. Does that help? Descending down. So let's go ahead and write this polynomial in descending order. So my first term would be x to the 5th plus x cubed minus x squared plus 2x. Does anyone have a question on how I did that? Are we good? Okay, and then it says identify the leading coefficient. The leading coefficient meaning the number in front, okay? The leading coefficient, we're not talking about exponent now. The leading, let's just get that so you can read it. The leading coefficient, so look at your first term. Is the number in front of your first term. Now that it's written in descending order. Does that make sense? Yes? Okay, so what's the leading coefficient? What is the number in front of the x to the 5th power assumed to be? It's a 1. So the leading coefficient here would be 1. So let's try another one together. Let's try another example, and then we'll let you go ahead. Let me leave that there in case someone's copying it. So let's try this problem. X to the 4th plus 4x cubed minus 7x to the 5th plus 1. So we're going to put in standard form. Standard form means the same thing as descending order. And we're going to state the lead coefficient. Does everyone understand what we're doing? Yes? Okay, so everybody go ahead and do that, and I will do it as well. Okay, we have one more topic that we're going to look at today, and that's adding and subtracting. Adding and subtracting polynomials. Okay, so how would we write this in order? Who's my line leader? What would the first term be, guys? Negative 7x to the 5th plus x to the 4th plus 4x cubed plus 1. And what would my lead coefficient be? Negative 7. Great job. Okay, we're going to move on to the second page in our notes, which is adding and subtracting polynomials. Adding and subtracting polynomials. And we've actually already done this year a little bit, but let's just go ahead and do a review. To add and subtract polynomials, we can group them together horizontally or write them in column form. Like terms, remember, are terms or monomials that have the same last name. They have the same variables with the same corresponding exponents. I'm going to really go ahead and suggest for you all that we use the horizontal method only, because sometimes when people use the vertical method and they subtract, they forget to change the sign. So I think this might be easier for you guys. Okay? So let's just go ahead and take a look at it really quickly. So we're going to look at this first example here, and we're going to look at using the horizontal method and what happens. Let's make sure we know the definition of like terms. Okay? And again, I prefer the horizontal method for you guys. I think you're less likely to make a mistake, and in the long run, I think that's what it's all about. So let's go ahead and do the first problem together. We'll do the first one together.
The first thing we can do something is add in the second speed. I accidentally.
This was the same page we all got. It's okay.
Okay.
Let's just go either way.
Okay.
Just go ahead and select. All right, adding and subtracting polynomials. Adding and subtracting polynomials. Here we go. Let's use 3x squared plus 2x minus 6. Of course, they start us off with a nice subtraction one. Minus the quantity 2x plus x squared plus 3. So the whole key here is when you subtract, you have to make sure that you distribute the minus sign. Are y'all with me? Come on, guys, wake up this morning. Are y'all with me? Okay, good. So then the next thing we would do is this. We would actually remove the parentheses from the first term, from the first parentheses. And now we're going to distribute. This would become a minus 2x, a minus x squared, and a minus 3. And now we're ready to find like terms. So I have a 3x squared minus x squared, which gives me a 2x squared. I have a 2x minus 2x, which gives me what, guys? 0. And I have a negative 6 minus 3, which gives me a minus 9. Final answer. Do y'all remember doing this? Okay. Okay, let's try another one. And that one is in your notes, so you can refresh and go back there. Here is example number 2. 4a minus 5 plus 3a plus 6. So when we're adding, you could remove both parentheses and solve. 4a minus 5 plus 3a plus 6. The like terms here would be 4a plus 3a, which gives us what? 7a. And then we have a minus 5 plus 6, which would give me a plus 1. Okay? Does anybody have a question? Okay, so tonight in your homework, if you were to look at your homework is going to cover pretty much a little bit of everything that I covered today. So you are going to add and subtract. You're going to determine if it's a polynomial, find the degree, and then state if it's a binomial, monomial, or trinomial. And then the last section is writing in standard form and identifying the lead coefficient. Thank you for listening to us today. I hope you all have a great day.